So today we're doing 11.5. This is page 901 in your book, and we're going to talk about transformations. So the transformations, remember, are always your A's, your H's, and your K's. Okay, so real quick, this is going to be your parent function for all log functions. Remember, log is the inverse of an exponential function. So we're going to have an A value in front. That always stretches. It's a log function, so you're going to see the word log in there. If there's a base, it'll be written right down here as your base. If it's not there, remember it's base 10. And then you will have x minus h, remember h goes right and left, plus k up and down. And that's your generic parent function for a logarithm. Remember, for a logarithm, your parent table is the inverse of an exponential. So exponential, we had x's that were -1, 0, and 1, so now those are the y's. And we had y's that were 1 over the base, 1, and then the base, so those are our x's now. That's your parent table for all logarithms. Just switch the x's and the y's, and then all these things happen. A's stretch, h's move right left, k's move up down. Okay. So as we go through this, I'm just going to show you, let's see, I'm going to skip over 5 and kind of show you some key points. Now this equation is f of x equals log of x. So if it's log of x, that should hopefully tell you something. It should tell you the base is 10. So this parent table should be -1, 0, 1 for the y's now. At 0 we have 1. At 1 we have the base. And at -1 we have 1 over the base. So look at your graph here. Here's 1, 0. 10, comma 1. Well, here's 1. I'm looking at this point. Here's 1, and it looks like way over here is going to be that dot. So you can see 8, 9, 10, and there it is, 10, comma 1. And then 1/10 is really small, close to 0, and it's negative. 1/10, -1. Here's 1/10 maybe, and then there's -1. So what happens is we get an asymptote going up and down at x equals 0. Now our asymptote is always x equals h, whatever our h number is. Notice h here is 0 because it's x minus 0. You can't see it. So how do we move this function? Well, right here, what I want you to do is to describe this first. Describe it. Well, here's an a value. Here's an h value. So if I describe it, we are going to stretch times 3. Describe it, we're going to go left 2. Left because it's always x minus h. Okay? So what we're going to do is we're going to take that parent table that you just saw right here, 1/10, 1, 10, -1, 0, and 1, and we are going to transform that. I'm going to do it in red. Alright, so if it goes left 2, this is an h value. The left will affect the x's only, so we're going to do x minus 2. And we're going to take these numbers and subtract 2 from them. 1/10 is a little bit tricky to do, so let's do 1 first. 1 minus 2, -1. 10 minus 2, 8. And now 1/10 is basically, 1/10. If we're subtracting 2, though, let's see. You could probably do that on the calculator, but it looks like it's going to be -1 and 9/10. Almost -2 because 1/10 is almost 0. What are we going to do to the y's? Well, the y's are going to be stretched times 3. So this is a 3 times y value. Alright, so 3, if we multiply it by -1, 0 multiplied by -1, 1, I keep saying -1, I'm sorry. 3 multiplied by -1, 3 multiplied by 0, 3 multiplied by 1. So this is our table of points. And you can go ahead and put this into your calculator if you'd like and verify some of our points. Okay, this one might not come in on your table because it's a fraction, but these two should. So we're at -1, comma 0. We're at 8, comma 3. And we're at almost -2, comma -3. So -2, -3 is here, but then we're a little less than -2, so it's going to go right there. And the graph, this first point is always going to kind of tell you where you're graphing your line down. And there's our graph. Notice we have an asymptote here. And this asymptote is x equals, because it's up and down. Vertical lines are always x equals. What number are we at? 1, 2, negative. And that's our h number, -2. Alright, so try with your table to graph something like this. Use your table and figure it out. Well, with your table, what's it going to do? And what's it going to do over here? So hopefully you said, write 3, this is an h value. up 4, this is a k value. So how does this affect our table? Well, we'll use our parent table. Our log is base 10 because there's no number there. So we're negative 1, 0, and 1 for the y's. 1, 10, 1 over 10. We're going to change that according to these. So it's going to be x's plus 3. So add 3, add 3. This is almost 0, but if you add 3 to it, we're going to get 3 more than that, so 3 and a tenth. Remember, k's always affect y's, so it's y, and we're going up 4, so we add. That becomes 3, 4, 5. And now we can graph that point. So my question to you before you do it, where will your asymptote be? Well, your asymptote is your k number. Since your k number, or sorry, I apologize, your h number, because it's logs, it's going to be at the number 3. So I can tell right away there's going to be an asymptote right here. And then my graph 4, 4. 13, 5, I can't even put it on the graph, and 3 and a tenth, 3. So this little bit to the right of this, 3. It's basically going to look something like this and like that. So these are transformations of logarithm functions. All right, one more. What happens if we do a negative? Well, hopefully remember that negatives are going to flip your graph. So this will be flipped over the x-axis. This will be stretched times 2. There's your h of 0. There's no h because it's in parentheses. And then over here your k means it's going to go down 3. All of these are y manipulations. The only thing that affects x is your h number. So again, we're still on base 10. So negative 1, 0, and 1 are my y answers. 1, 10, 1 over 10. And we're going to transform that to our rules over here. Well, this is an a value. This is an a value. This is a k value. All of those affect the y's. So whenever you're writing, it's always the a number times y, plus or minus, in this case minus, the k value. And x's do nothing. X's will stay the same. Let's see, if we don't figure these out, all of these affect the y. So negative 2 times negative 1 is 2. Take away 3. There's our answer. Negative 2 times 0 is 0. Take away 3. There's our answer. And 1 times negative 2 is negative 2. Take away 3. There's our answer. What's going to happen is our graph's going to go upside down automatically. So let's see. We're going to have the point. I always skip this fraction one usually first. But 1 comma negative 3. 1 comma negative 3 will go there. 10. Negative 5 will go there. And now I'll do this one. This is almost 0, but it's positive. So it's a little bit to the right of 0. A little to the right of 0. Let's call that 1/10. And then we go down to negative 1. So somewhere right about here. And what happens is our graph is kind of going upside down to the right. But just like always, we will have a vertical asymptote always at x equals h. What's our h number? 0. So we have an asymptote at x equals 0, which means this is going to go straight up vertical. Now the only difference with a different graph is the base. Well, this is a base of 2. So that means on our parent table, x and y, since this is a log function, that means we flipped the x's and the y's. And notice we always did our x's as negative 1, 0s, and 1s. So we're going to do those for the y's. At 0, our answer is always 1. At 1, our answer is always the base. And at negative 1, our answer is always 1 over the base. So there's our parent graph. 1, 0, 2, 1, and 1/2, negative 1. And again, we still have a vertical asymptote. At x equals h, our h number is nothing, 0. So let's do this. This equation, let's describe it. 4 is an a value, so we are going to stretch by a factor of 4. It's log 2, so we're using this table to do all our work with. Our h is 1, so that means we are going to go right 1 unit. Our k is 3, so we're going to go up 3 units. As you can see it, this is a, h, k. Alright, to do our actual graph, we are going to write down our parent table. 1/2, 1, 2, negative 1, 0, 1. And the reason this is our parent table is because we are base 2. So this negative 1, 0, and 1 never changes. This 1/2 and this 2 are based off of that base of 2. Okay. Our table, however, for our graph is going to be a little different. Let's see, which one of these move the x's? X is only affected by h, so this one will affect x. We're going to go right 1, which means we're going to take all the x's and add 1 to them. This becomes 1.5, 2, and 3. Our a's and our k's will affect the y's. Remember, it's always a times y plus k. And we're going to take these numbers and plug them in. Negative 1 times 4 plus 3. 0 times 4 plus 3. 1 times 4 plus 3. Now I graph my points. Keep in mind before we start, since it's a log function, your asymptote will be at x equals h. Our h number is 1, so I already know I have an asymptote right here. Whenever it's log, it's a vertical line. Whenever it's exponent, it's a horizontal line. Plot these points. 1.5 comma negative 1, 2 comma 3, 3 comma 7, and here's our graph. It's kind of slowly going to the right and up. Notice this graph is a lot more vertical than this one because we're stretching it times 4. So it's taking this graph and elongating it. So it's going to be almost more of a straight line, but it still does curve off to the right in time. Okay? So this is all the explanations for logarithmic graphs and the transformations of them. Remember, the a's, h's, and k's still do the same thing that they've always done before, stretching, right movements, and up movements, only now we have a new parent table. Okay? Make sure you have these parent tables written down somewhere. Okay? You with your table can start looking on some of these. Log base 2, we're going to flip it. Left 3, down 4. Okay? The next one that we'll do is the natural log. Whenever you see ln, that is called the natural log. And we've talked about this very quickly in class, but the natural log is always base e. And just trust that e is a number. Okay, so this parent graph will still be negative 1, 0, and 1. We're in logs, so the x's and the y's still switch. It's just called the natural log. At 0, we always get an input of 1. At 1, we always get an input of our base. Well, our base is e, so all you have to do is write e. Okay, the calculator knows what that is, and hopefully you know that's 2.718, which is a little less than 3. So when you see e, it's a little less than 3, and what I always remember is e rhymes with 3, so that's about my number. And this is always 1 over my base. You can just put e's. So what we see here, let's go ahead and describe this. This right here, natural log of x, that's just our parent function. Just think of describing this as the a's, the h's, and the k's. Here's my a, my h, and my k. And just trust that this is still going to do the normal stuff. So when I say describe it, we're going to stretch by 3. We're going to go right 2 and down 4. So how does this make the graph work? Well, we're going to start here. 1 over e, negative 1. 1, 0. E, 1. And again, the reason we're e is because this is a natural log. ln means natural log. Let's transform this. Alright. H is a horizontal movement, so it's x's plus 2. And this is where it gets a little confusing to some people, but just trust like e is like its own. If I have a 1, I'm going to add 2 to it. That's pretty easy. If I have an e, I'm going to add 2 to it. So here's all you have to do. E plus 2. Good enough. 1 over e, we're going to add 2 to that answer. And all you have to do is basically copy the h, and then the only one that you really need to solve for is the 1. 1 plus 2 is 3. We know that, so we can write it down. Okay, and the calculator can show us what these answers are later on. We're going to stretch by 3 and move down 4. Those are both y movements, so it's always a times y minus, in this case, k. Alright, plug them in. Negative 1 multiplied by 3, and then subtract 4. That's a negative 7. 0 times 3 minus 4. 1 times 3 minus 4. And now we were going to graph this function. So keep in mind, I'll skip this to the end. This is the easiest one to graph, 3 comma negative 4. 3 to the right, negative 4 down. E, remember, is just less than 3. So think of this as 3. 3 plus 2, that's about 5. But if e is a little less than 3, then this whole answer is a little less than 5. So we're going to go 5 and then back off a little for x. And then come down 1. That's good enough for me. So far, we can see that it's a log graph, so it's still going to go off to the right. So this is going to go off to the right, something like that. And now think of this as 1 over e, which think of it as 1 over 3, 1/3, because e is about 3. 1 over 3 plus 2, that'd be about 2 and 1/3. So we're going to go to 2 and then a little more than 2. And then we're going to go down 7. So something right about here. So our graph's going to do this. And remember that our vertical asymptote is always at our h number, which in this case is positive 2, because it's always the opposite of the h. Notice here's our vertical asymptote. Alright, all of these are the exact same ideas. Now the next thing we need to do is talk about domain, range, and asymptotes. We've kind of talked about this. But for all log functions, the domain is all real numbers, and the range always goes from 0 to infinity. And you can see your graph here. We've talked about these in the past. So it's the same for all log graphs, unless you move it. But the important thing here is our asymptote is always your x equals your h numbers for logs. In this case, my h number is 2. Okay, so this is the parent, and you are supposed to translate it according to this. So our asymptote is going to be x equal 2. I would always start right there. So our new graph is going to go here. And then we are going to translate, let's see, we're going to go 2 right and 6 down. So take each point, go 2 right and 6 down. 1, 2, 3, 4, 5, 6. Take this point, go 2 right, 6 down. 1, 2, 3, 4, 5, 6. Take this point, go 2 right. So it's a little bit to the right of here, a little bit right there, and then 6 down, we'll go down here, and notice now we have our graph. So we don't have to create a parent table now, we just have to translate it. Okay. This one here, let's go ahead and do all the information here first. Let's see, that means it's going to flip, and then up 3. So if we're on here, we're going to flip it. Remember, it always flips over the x-axis. So let's do this point first. If it flips over the x-axis, comes here, and then goes up 3. 1, 2, 3. Seems a little weird. We didn't go right or left because there's no h. This one flips over the x-axis, so it stays still, and then goes up 3. 1, 2, 3. This one flips over the x-axis, so now it goes right there. So it's flipping like you fold your page, and then up 3 still. 1, 2, 3. And now what we're going to do is we're going to get a graph that's upside down because it flipped. And I don't know exactly where it's going to hit, but something like that. We still have our asymptote here because the asymptote did not move right. This time it is no longer actually I realize now I did that wrong, so I apologize. I'll come back to that. The domain is all your x inputs, so the domain is from 0 to infinity. I actually wrote these backwards. And I was thinking exponential, and remember logarithms, we flipped them. Okay, so this is written backwards. The range here will go up forever and down forever, so the range is what's all real numbers. Our asymptote is still at x equals h. In this case, our h is nothing because there's nothing written right there, so x equals 0. So that's explanations of how to actually graph transformations just given an equation. Whenever it says f of x, just use it based off of whatever your f equation is that's already drawn. Here's my f of x. It's already drawn for you. Okay. Alright, the last couple things we want to be able to do is just to be able to match some of these functions. Okay. And ultimately what you just need to do is understand that these are inverse graphs. Here's 2 to the x power and log base 2 to the x power. And on a test, if I say, are these inverses, an easy thing to do is always to graph a horizontal line from the bottom left to the top right. This is called the line y equals x. And you can just check, is everything reflected over that line? For example, these two, if you folded your page right along this line, they would match up, they would match up, they would match up, they would match up. So this is an example of an inverse graph. And all of these are the same graphs. But I just want to make sure that you know that this is how you can see visually that 2 to the x power is the inverse of log base 2 of x. Because remember, we rewrite these, by the way, 2 to the x power, if you rewrite it as a logarithm, log base 2 of y equals x. Remember, we said we always trace the L for our situation. Actually, I should put y here, because our inputs and our outputs is switch. Inputs and outputs. Log base 2 of y equals x. Okay. So all of these, we are going to try to transform them and understand what's going on. At this point, let's